Hi everyone, today we'll be looking at the June 2019 P2 paper. So we've got a sequence in question 1, A1, A2, A3 defined by these recurrence relationship. So the next term is 4 minus the previous term and we start at 3. So this means that A2 will be 4 minus A1, which is 4 minus 3, which is just 1. Now for A107, I'm just gonna proceed in finding the next term. So A3 is 4 minus A2, which is 4 minus 1, which is 3. So we have just established that we go 3, 1, 3. So there's a repeating pattern here. 3, 1, 3, 1, 3, 1. So it's easy to see that the odd terms are all 3 and the even terms are all 1. So this means that A107 must be a 3. In B, we need to evaluate this sum from 1 to 200 of 2an minus 1, which simply means 2a1 minus 1 plus 2a2 minus 1 plus 2a3 minus 1 plus ... with the last term being 2a200 minus 1. Now 2 times the first term, well the first term was a 3, 2 times 3 minus 1 is 5, 2 times the second term minus 1 is 1. So we will be having this situation repeating for a total of 100 times because we've got 100 such pairs. And each pair is contributing a total of 6. So this will be 100 times 6, which is just 600. Question 2, it's a circle with this equation and we need to determine the coordinates of the center and the exact value of the radius. I will start by writing the x terms together. So x squared plus 4x plus y squared minus 10y minus 21 is 0. This is calling for completing the square. So we've got x plus 2 all squared minus 2 squared plus y minus 5 all squared minus 5 squared minus 21 is 0. So x plus 2 squared minus 4 plus y minus 5 squared minus 25 minus 21 is 0, which means that we've got x plus 2 all squared plus y minus 5 all squared is equal to 50. Now that we know that if the circle has a center alpha, beta, and the radius r, then its equation would be x minus alpha squared plus y minus beta squared is r squared, and therefore I can easily conclude that the center should be -2, 5, and the radius should be root of 50. The next part says that the point P with coordinates 5, 4 lies on C, and we need to find the equation of the tangent to C at P. It makes sense to draw a quick sketch. We've got a circle. This circle is centered at -2, 5, and we've got the tangent. So it's a line that just touches at a point. We know that the angle between a tangent and the radius at the point of contact is 90 degrees, and this is the point 5, 4. I will start by finding the gradient of the radius because I've got 2 points on this radius. So it's gonna be 4 minus 5 over 5 minus -2, which is minus 1 over 7. This means that the gradient of the tangent, I'm just gonna flip it and change the sign, it's 7. I'm using the equation y minus y1 is mx minus x1 because I've got the coordinates of the point and the gradient. I will expand. Y minus 4 is 7x minus 35, leading to y is 7x minus 31, and matching the required form. Question 3, we need to use algebra to prove that x minus 4 all squared is greater than or equal to 2x minus 9. I don't really have a good starting point here apart from the statement itself. So this is not a formal proof yet, it's what we call the jottings. It's a rough work. So if I was to start from what I have to show to be true, x minus 4 all squared greater than or equal to 2x minus 9, I would expand, leading to x squared minus 8x plus 16 greater than or equal to 2x minus 9. Collecting everything on one side, it's x squared minus 10x plus 25 greater than or equal to 0, which is a perfect square. Now we know that it is certain that if x is a real value, then x minus 5 all squared has to be greater than or equal to 0. And this is really the starting point I was after in order to construct a valid mathematical proof. So, x minus 5 all squared is greater than or equal to 0 for all real values of x. I'm just gonna be repeating all these steps in reverse order. So, if I expand, x squared minus 10x plus 25 is greater than or equal to 0. So x squared minus 8x plus 16 is greater than or equal to 2x minus 9. So x minus 4 all squared is greater than or equal to 2x minus 9 as required. Remember, because it's a prove that question, we need a conclusion, and the minimal conclusion in this case would be the as required. In II, we need to show that this statement is not true. So 2 to the n plus 1 is a prime number for all values of n. And in the natural numbers, these are the positive integers, the natural numbers. So we just need a counter example. And through some trial and error, we say that n is 3, 2 to the n plus 1 is 2 to the 3 plus 1, which is 9, which is 3 times 3. It's not a prime, it's a composite number, the 9, and therefore the statement is untrue. In question 4, it's a binomial expansion. I need to find the first 4 terms in ascending powers of x for this. So we've got 2 minus a quarter x raised to the power of 6. I start with the full power loaded on 2, and then 6 choose 1, 2 to the 5 minus a quarter x to the power of 1, plus 6 choose 2, 2 to the 4 minus a quarter x to the power of 2, plus 6 choose 3, 2 to the power of 3 minus a quarter x to the power of 3 plus dot dot dot. We haven't been told to simplify, but I'm actually gonna do that. And just as a reminder, the choose notation is giving you the binomial coefficient. You could also derive it from Pascal's triangle. And notice that the powers always add up to the number here. I will proceed now. This is 2 to the power of 6 is 64, plus 6 times 32 times minus a quarter x, plus 15 times 16 times 1 over 16x squared, plus 20 times 8 times minus 1 over 64x cubed plus dot dot dot, which simplifies to 64 minus 48x plus 15x squared minus 5 over 2x cubed. And then in part B, given that x is small so that we can ignore x to the power of 4 and higher powers of x, we need to show that this holds true for constants a and b to be found. Now we notice that we've got the expansion for 2 minus a quarter x to the power of 6, and the only difference for 2 plus a quarter x to the power of 6 will be that we will not have any negatives here. It's just gonna be positives, so it's gonna be 64 plus 48x plus 15x squared plus 5 over 2x cubed plus dot dot dot. I'm gonna write what we just found for 2 minus a quarter x below, just to see what's happening. 64 minus 48x plus 15x squared minus 5 over 2x cubed plus dot dot dot, which means that if I add them up, I will see that 2 plus a quarter x to the power of 6 plus 2 minus a quarter x to the power of 6. The odd powers will cancel out, and I'm left with 128 plus 30x squared. In question 5, we've got a company that makes a particular type of watch. The profit is given by this expression. Notice that the profit is in thousands of pounds, and we need to use calculus to find the maximum possible annual profit. So we want dp dx. We get the power down, deduct 1 from the power. We will set this equal to 0 if it's a maximum, so dp dx is 0, which means that 12 minus 3 over 2x to the half is 0. 12 is 3 over 2x to the half, leading to 24 is 3x to a half, so 8 is x to the half, which means that 8 squared is x, so 64 is x. We haven't finished part A. We need to find the maximum possible annual profit. What we have just found is the price, the selling price of the watch that will maximize the profit. So I'm just gonna say that when x is 64, P is 12 times 64. I'm substituting 64 into the expression for P, minus 64 to the 3 over 2 minus 120, which turns out to be 136, and therefore the profit is 136,000 pounds. If you stop at 136, you will be penalized. The last mark will not be awarded. Now B, justify also using calculus that the profit you have found is a maximum. So we actually need to consider the second derivative, the 2p by the x squared, which is minus 3 over 2 times a half x to the minus a half, which is minus 3 over 4 x to the minus a half. I will substitute into this expression for the second derivative. The value of x is 64, we just found. So minus 3 over 4 times 64 to the minus a half. And this gives an answer of minus 3 over 32. It turns out to be negative. You need to explicitly show the comparison with 0, and you conclude that therefore it must be a maximum. If you do not compare with 0 and you just say minus 3 over 32, therefore maximum, you will not score both marks. Question 6, we've got f of x here. It's a cubic, k is a constant, and we're being told that x minus 3 is a factor of f of x. We need to show that k is 9. So if x minus 3 is a factor, it must be the case that f of 3 is 0. So I will substitute k times 3 cubed minus 15 times 3 squared minus 32 times 3 minus 12 is 0, which leads to 27k minus 135 minus 96 minus 12 is 0, and therefore 27k is 243 So k is 243 over 27, which is 9 as required. B, using algebra and showing each step, fully factorize f of x. Now that I know that x minus 3 is a factor, I can proceed with a long division. 9x cubed minus 15x squared minus 32x minus 12 divided by x minus 3. Remember, we're always trying to match the highest part of x here. So x needs to be multiplied by 9x squared, so 9x cubed, minus 27x squared. I put my minus here, and I get 12x squared minus 32x minus 12. I need to multiply it by 12x. I get 12x squared minus 36x. Again, subtraction, 4x minus 12. So I have a plus 4 here. So it confirms that x minus 3 is indeed a factor because it leaves a remainder of 0, and allows me to proceed in saying that f of x is x minus 3 times 9x squared plus 12x plus 4, which further factorizes into x minus 3, 3x plus 2, 3x plus 2. This completes part B. Part C says solve for 0 to 360 this cubic in cos. Well, we have to realize that the x became cos theta. So I will start by solving f of x is 0. So if we've got f of x is 0, this means that either x minus 3 is 0 or 3x plus 2 is 0. So either x is 3 or x is minus 2 over 3. Now we said that x has been replaced with cos theta, so either cos theta is 3 or cos theta is minus 2 over 3. Now cos theta cannot be 3, this has to be rejected, not valid, because cos theta always attains values between minus 1 and 1. And now for cos theta being minus 2 over 3, I will do shift cos to find my principal value. Shift cos of minus 2 over 3, which is 131.81. So theta is plus minus 131.81 plus 360. And I had to give answers to one decimal place between 0 and 360. So the only two solutions are 131.8 and 228.2. Question 7, we've got Kim, who starts working for a company. She starts with an annual salary of 16,200. In year 10, she's predicted to get 31,500. And under model A, we're assuming a fixed increase per year. And we need to find, according to this model, her annual salary in the second year. So we're essentially looking at an arithmetic sequence with first term 16,200, that's A, and second term 10th term 31,500. We know that for an arithmetic sequence, the nth term is A plus n minus 1d. So this will be A plus 9d, replacing n with 10. I could deduct this one minus that one, and we get 15,300 is equal to 9d. So 15,300 over 9 is equal to d. So 1700 is the value of d, and therefore the second term, which is just a plus d, will be 16,200 plus 1,700, which is equal to 17,900. Now we've got the second model, it's called model B, which is assuming a fixed percentage increase per year. So this is a geometric sequence. I'm multiplying by the same number known as the constant ratio R to get to the next year's salary. So for this model B, we've got that we start with, again, 16,200, that's A again, and the 10th is 31,500, but we know that for a geometric sequence, the nth term is AR to the n minus 1. So it's gonna be A times R to the power of 9. So I could simply say that if I divide this by that, I get 31,500 over 16,200 is AR to the 9 over A. This means that the A's will cancel out, and we get that R is the 9th root of 31,500 over 16,200. I'm not gonna be rushing to the calculator. I'm not really interested in the value of this because I need to find, according to this model, the annual salary in year 2, giving our answer to the nearest 10 pounds. So the second term is simply AR, which is 16,200, times the value of R we have just found. I will plug everything on the calculator now, and it's giving me 17,442.29, which will be rounded to 17,440 to the nearest 10 pounds. In C, we need to calculate, according to the two models, the difference between the total amounts, keyword here being total, predicted from year 1 to year 10 inclusive. We need to give answers to the nearest 10 pounds again. So we need to find the sum of the first 10 terms for each of the two models. So under model A, let's remind ourselves that the sum of the first n terms is n over 2a plus n minus 1d. So in our case, S10 will be 10 over 2. We have found the value of A to be 16,200 and the value of D to be 1,700, and this gives an answer of 238,500. For model B, the geometric sequence model, we know that the sum of the first n terms is A1 minus R to the n over 1 minus R. So it's gonna be S10 is 16,200, and we've got 1 minus the value of R, 31,500 over 16,200, the 9th root of this, raised to the power of 10 because I'm summing up the first 10 terms, over 1 minus R. You have to be careful with the calculator here to avoid any mistakes. And if you plug everything correctly, you get an answer of 231,019.24. We are interested in the difference of 238,500 minus 231,019.24 is equal to 7,480 pounds to the nearest 10 pounds. In question 8, we need to find the exact solution. The first part, 8 to the 2x plus 1 is 6. We need to give our answer in this particular form. We need to be careful. We need to match that form. A and B are constants to be found. So we've got 8 to the 2x plus 1 is equal to 6. It makes sense to start by taking logs of both sides and actually log to the base of 2, because I see that the answer is to the base of 2. The power law of logarithms says that 2x plus 1 can come down and I notice that 8 is 2 to the power of 3. So I'm writing this down. So the 3 can come down. 3 brackets 2x plus 1 log of 2 base 2. And actually I will consider 6 here as 2 times 3. So I will write log of 2 base 2 plus log of 3 base 2. The reason I did this is that log of 2 base 2 is 1. And therefore on the left I expand to get 6x plus 3. And on the right I've got 1 plus log of 3 base 2. So at least I'm dealing with the log of 3 base 2, which is part of the form of the answer I need to arrive at. Now this means that 6x is minus 2 plus log of 3 base 2. So x is minus 2 over 6 plus a sixth log of 3 base 2, which can be written as minus a third plus a sixth log of 3 base 2. In II, using the laws of logarithms, we need to solve this. So I will start by writing out the given equation. I've got log of 7 minus 2y to the base of 5 is equal to 2 times log of y plus 1 to the base of 5 minus 1. I will start by writing log of 7 minus 2y base 5 is log of y plus 1 squared base 5 due to the power law of logarithms. I will collect all the logs on one side, so maybe I could make things a bit easier for me if I just say that 1 equals to log of y plus 1 squared minus log of 7 minus 2y base 5. I've got log minus log on the right hand side, which is log of y plus 1 squared over 7 minus 2y to the base of 5. I can now remove the log by saying 5 to the 1 is y plus 1 squared over 7 minus 2y. If I cross multiply, I get 35 minus 10y is y squared plus 2y plus 1. Obviously, this is leading to a quadratic in y, so 0 is y squared plus 12y minus 34. And I need to proceed. I'm gonna use the quadratic formula here. So y is minus b plus minus b squared minus 4ac over 2a, and I get the values of minus 6 plus minus root of 70. Now I cannot just accept both answers. I need to go back to the original expression here. I need to make sure there is none of these two values that causes an issue in the original equation. So we want the 7 minus 2y to be greater than 0 and the y plus 1 to be greater than 0. So 7 minus 2y being greater than 0, this means that 7 is greater than 2y. So we have 7 over 2 greater than y. And y plus 1 being greater than 0 means that y has to be greater than minus 1. So we want solutions between minus 1 and 7 over 2. And it's easy to check that minus 6 minus root 70 is not a suitable answer. So I'm just going to stick with y being minus 6 plus root 70. There was no indication from the question itself on the existence of a single solution. It's just said solve, so it could be one or more solutions, but I had to manually check against the original equation in order to verify that both are compatible with the original equation. In question 9, we need to show that this equation can be written in that form. So I will actually start off by cos theta minus 1 is 4 sine theta tan theta. It makes sense to write tan theta as sine theta over cos theta. And the next obvious step is to multiply throughout by cos theta in order to get rid of the denominators of the fraction. So cos squared theta minus cos theta is 4 sine squared theta. Now we know of the identity sine squared theta plus cos squared theta is equal to 1, which will allow me to express the sine squared in terms of cos squared. So cos squared theta minus cos theta is 4 brackets 1 minus cos squared theta. So I will expand cos squared theta minus cos theta is 4 minus 4 cos squared theta, which leads to 5 cos squared theta minus cos theta minus 4 is 0, which is exactly what the question was asking me to do. So as required. And then in B, it says, hence solve for x between 0 and pi over 2. So we are in radian mode. This equation here. If you just compare, you see that the theta became 2x. So this means that the result we have just established here can be written as 5 cos squared 2x minus cos 2x minus 4 is 0. I will let w be cos 2x just to see this disguised quadratic. It's 5w squared minus w minus 4 is 0, which factorizes into 5w plus 4, w minus 1. And therefore, I can say that either 5w plus 4 is 0 or w is 1. This means that w is minus 4 over 5, or which means that cos of 2x is minus 4 over 5, or cos 2x is equal to 1. Now, I will find my PVs. My PV will be shift cos of minus 4 over 5, which gives me an answer of 2.4981, or shift cos of 1, which is 0. So 2x is 0 plus 2 pi n, which means that x is pi n if I divide throughout by 2. And for the 2.4981, I get 2x is plus minus 2.4981 plus 2 pi n. Again, I'll divide everything by 2 to leave x on its own. It's plus minus 1.249 plus pi n. And I can now start generating solutions between 0 and pi over 2 by substituting integer values for n. It turns out that the only solutions are 0 and 1.25. From the question itself, I was expecting some exact answers and some non-exact answers because it says where appropriate. And I'm quite happy that I got an exact answer of 0 and the 1.25, which was given to 2 decimal places. In question 10, we've got a sketch of part of the curve shown here, f of x, and using calculus, we need to find the range of values of x for which f of x is increasing. Now, first of all, we could remind ourselves that if f of x is increasing, we just need to solve f dash of x, greater than or equal to 0. So, I will actually start by writing f of x in a form that can be differentiated. It's 36x to the minus 2 plus 2x minus 13. F dash of x is minus 72x to the minus 3 plus 2. And I will start by setting this to be equal to 0. So this means that 2 is 72x to the minus 3. So 2 is 72 over x cubed. So 2x cubed is 72, which means that x cubed is 36 and x is the third root of 36. Now, if f dash of x is 0, it's the minimum or the maximum point, it's a turning point, and because we were lucky enough to be provided with the sketch of the curve, this here is the value of x being third root of 36. We see that any tangent drawn after this point will have a positive gradient. If you were to draw this from left to right, you always go up, so you are increasing. The derivative is greater than or equal to 0, so I can simply say that I'm increasing for x greater than or equal to the third root of 36. You could write a strict inequality here or a relaxed inequality. Both of them are acceptable. In B, I need to show that this integral here is equal to 0. So I will just integrate from 2 to 9. Again, I will write it in a form that allows integration to take place without any mistakes. So I will write it as 36x to the minus 2 plus 2x minus 13 with respect to x. I increase the power by 1, divide by the new power. No need to include a constant of integration because we've got boundaries here. It's a definite integral. From 2 to 9, I will write this as minus 36 over x plus x squared minus 13x from 2 to 9. So I will substitute the upper limit and then the lower limit and deduct one from the other and put everything on the calculator, and we indeed get an answer of 0 as required. You need to show the substitution of the limits and with the upper limit being deducted from the lower limit and all of that, and we indeed got the 0. Part C, we are told that the integral from 2 to 6 is minus 8, and we need to state the value of this integral. We need to understand exactly what we have found and what has been provided to us. First of all, we have found that the integral from 2 to 9 is 0, and the integral from 2 to 6 is minus 8. We also know that P is 2, 0 and Q is 6, 0. So if this is 2 and this is 6, the fact that the integral from 2 to 6 here is negative 8 means that this area is 8. It's just negative because it lies entirely below the x-axis, and we have found the integral from 2 up to 9, and which is all of this area here, when we have found this to be 0. This mathematically means that this area and this area are equal in size. The two areas are equal. It's just that from P to Q, this part here lying entirely below the x-axis is negative, and so this part here should be 8, so that the minus 8 and the 8 give me a total of 0. That's why it says state the value of in part C, I, and the answer should be just 8. And then II, we need to find the value of the constant k such that this is 0. So we have to essentially solve this from 2 to 6, 36 over x squared plus 2x plus k with respect to x is 0. I will be using what I have found up to now. I'll try to squeeze in a minus 13. So I will add a 0 intelligently into my integral. So plus 2x minus 13 plus k plus 13 with respect to x is still 0 because I have just added a 0 in the integral. So I haven't really done anything. But now I can split this integral into the integral from 2 to 6 of 36 over x squared plus 2x minus 13 with respect to x, plus the integral from 2 to 6 of k plus 13 with respect to x. And we do know that this here is just negative 8. This is what we've been told by CI. So this means that minus 8 plus the integral of k plus 13, well, k and 13 are constants, so it's just the x brackets k plus 13 from 2 to 6 is equal to 0. So x brackets k plus 13 from 2 to 6 is 0. 6 brackets k plus 13 minus 2 brackets k plus 13 is equal to 0, which leads to it's equal to 8. Let me make that correction there, 8 and 8. So 4 brackets k plus 13 is equal to 8. So k plus 13 is 2, which means that k is negative 11.